Hey, so in this short how-to video, we'll go through how you can export a black oil PBT table into Harmony. So the first thing you need to do is to find your relevant val within Whitson PBT. Then go to the lower right and click the Harmony export button right here. Then just store this file somewhere locally on your computer such that you can easily access it, and then open both Harmony and this Excel file at the same time. For those of you who are seasoned users in Harmony, you know that PBT properties are inputted under analysis and under editors, and specifically in this navigation panel right here under gas and oil respectively. In the output file, the most important and relevant sheet would be the data sheet that has all the different PBT properties in its relevant format, and we have on purpose actually colored these values in green for the oil-related properties and red for the gas-related properties. There's also a few things under the fluid init pane right here, this fluid init sheet that we'll also use when importing this data. So when starting, we need to first input some reservoir properties, and the reservoir properties you probably know very well yourself, but they're also given in the fluid init information sheet that's exported from Whitson PBT. This number is 6,500, so the initial reservoir pressure is 6,500 in this case. The reservoir temperature is 200 Fahrenheit. For the sake of just importing this table, the height and RW and porosity doesn't really matter for this demonstration. So we'll just put in some random numbers here, and then we know that this particular case is initially undersaturated reservoir oil. So we'll include no gas saturation, and just for simplicity we'll keep it at 0 water saturation as well. So the relative saturation between oil and gas is given here. So if it's two-phase saturated, you would have a oil saturation and then a gas saturation that would be higher than 0. But here we have a single phase system in situ, so it's a little bit simpler for us. The first thing to do is to go to the oil/condensate input tab, and then change these default correlations to custom table, both for the PBT properties and the viscosities. While we are in this particular screen, we can input both the API gravity, which is 50 in this particular case, and the saturation pressure, or the bubble point, which is 4,535.53. And that you input in the second window right here. Good. So now we jump back to the data tab to essentially just input these different columns. The first thing you can note is that we've defined or marked the different rows in this table by saturation type, whether it's saturated or undersaturated. The reason why you need that is because in Harmony you actually have one window where you're only supposed to input the saturated oil properties, and then one second window where you're only supposed to input the undersaturated oil properties. So just to make it clear, we'll in this first window right here input only the saturated properties, and here it's important to also include the saturation pressure, which in this case is a bubble point, because per definition a bubble point or a saturation pressure is a saturated point. The same goes for the formation volume factors, and just make sure that you have the same number of columns and that the values are the same in terms of pressures. And then in the second tab right here, we've already filled in the saturation pressure, but we will also input the undersaturated properties for BO, which in this case is just 2 points right here and also indicated by undersaturated right there. The last thing we'll do is to include the viscosity values. Here all the saturated and undersaturated properties will be inputted at the same time. Then we're 50% done with importing the table. And the last thing we'll do is to import the gas specific PVT properties. And similarly to the oil case, we'll change these PVT correlations and viscosity correlations from default to custom table. And there's also one other thing we need to do in Harmony, which is to change the gas type to liquid-rich gas. And what that essentially does is that then we will start to account for condensate that is in solution with the reservoir gas, which is important for a lot of unconventionals, especially in fields that span a wide range of fluids, such as Montney, Duvernay, Scoop-Stack, Permian, Eagle Ford, Vaca Muerta, etc. So we do that, and the way we call it quantify that and represent that at different pressures is with this thing that we call the solution CGR. We also call it the vaporized oil ratio. It's either given by a large RV or a small RS. And we change that from a constant RV to a custom table as well. And then we get these values to import in the third pane right here. While we're at it, before we start to input these other values, it can be worthwhile also importing the dew point. And to make sure that you have a consistent black oil table for both oil and gas properties, you input the same dew point as what you had inputted as a bubble point in the oil pane right here. So this bubble point number and this dew point number should be the same, and that's for consistency, and is something that is also applicable to other simulators and the reservoir engineering softwares as well. So we've done that. We can also here make sure that the API gravity is the same, and that's actually an intrinsic or kind of like an inherent assumption when creating a black oil table, that the condensate that is in solution with the reservoir gas and I guess the surface liquid that's also produced from the reservoir oil phase has the same API gravity. So that's the simplification, but just for the sake of this black oil table, just make sure that the gravity here is the same as the gravity in the oil / condensate. And these two cells are actually linked, so that should be done automatically. The last thing we can also just do here is to input the CGRI that we find under the fluid init pane right here. And then after that we can flip back to the data sheet such that we can import these different tables. Good. So the first thing we'll start with is the formation volume factor for gas. For gas, we'll import 3 different columns: pressure, the C factor, and the wet formation volume factor for gas. And we'll talk a little bit more about this later. Then in the second window, we'll input the viscosities. And in the third window, we'll input the pressure and RV. Right here. Excellent. Now we can also see these properties being plotted up by clicking. So if you click this pane right here, you see they flip back and forth between plotted values and table values. And you can also do that the same for oil properties right here. So if we go back to gas, one thing that's important to emphasize is that the values that you're using in your reservoir simulator for formation volume factor for gas is this dry formation volume factor right here. And all other tables that you export from Whitson PBT would actually give you this property or this column directly. But in Harmony, you have to import the wet formation volume factor and the associated properties such that you internally in Harmony calculate these dry gas formation volume factors. And that's why, just for a kind of quick quality check, that we've included in this gray column to the right here, just the values generated by Whitson PBT, such that you can easily just copy paste these internally calculated values from Harmony into Excel, just to make sure that these properties are close to each other. And we see that these are very similar just by looking at them visually, but also if we calculate the residual. Good.